So, our discussion is all about bridge and transportation engineering, the two subdisciplines of civil engineering. Our objective is to gain a comprehensive understanding of bridge and transportation engineering, to develop a critical appreciation and comprehensive understanding of method and structural idealization and analysis of bridge structures and transportation system, to also develop a critical awareness of the different types of bridge and transportation systems and vehicles. And then, this is the outline of our topic. First, we will talk about the bridge engineering. We will know its definition and its importance, the types of bridges, and the forces that influences different bridge designs. Second, we have the transportation engineering. We will discuss its importance and its definition, the transportation systems, and the different branches of transportation engineering. Within the broad field of civil engineering, there are several subdisciplines. Bridge and transportation engineering are two of those subdisciplines. Bridge engineering is a civil engineering discipline that falls under structural engineering, but it is also related to transportation engineering because it entails the planning, designing, construction, operation, and maintenance of bridges to ensure the safe and efficient transportation of vehicles, people, and goods. In this report, we will discuss further the two of the subdisciplines under the field of civil engineering, which is the bridge and transportation engineering. We will provide the meaning, importance, and other relevant information about the bridge and transportation engineering. At the end of this report, you will find out what are the benefits we gained from these subdisciplines of civil engineering and the impacts they brought to our society and to the world as well. There are also learning activities that will be provided after the discussion to assess your learning from the discussion. First, let's talk about the bridge engineering, its definition, purpose, and how these bridges they constructed and designed help us in our daily lives. One of the disciplines of civil engineering is the bridge engineering, which involves the planning, design, construction, operation, and maintenance of bridges to ensure safe and effective transportation of vehicles, goods, and especially people. Designing and maintaining bridges is no easy work. That's why it is important and required for bridge engineers to have skills such as analytical thinking, supervisory skills, organization, and creativity. Bridges plays an important key role in our lives, and it connects our community, promoting commerce travels and contributing to our country's economic development. That's why it is important that bridges are built safely and correctly for effective use. Bridges covers the gap for reasons such as bodies of water, cliffs, and even valleys. Bridge engineers are responsible of these huge, simplest structures, magnificent product of art that we people benefit and helping us in our daily lives. Example of the bridges as you can see on the screen is the Brooklyn Bridge from Manhattan and the Golden Gate Bridge that links the San Francisco to Marin County. Now, let's go on to the different types of bridges. Let's find out how they differ in structure, purposes, and how they work. First, we have the arch bridge. It is the oldest bridge among the types of bridges and it is commonly used during the ancient times. It usually spans between 200 to 800 feet. The basic principle of arc bridge is its curved design, which does not push load forces straight down, but instead they conveyed along the curves of the arc to the support on its end. The support are called abutments, which carry the load and keep the other ends of the bridge and every part of the arc is under compression. The pictures shown are the examples of arc bridge: the New River Gorge Bridge, located in Fayetteville, West Virginia, and the Alcantara Bridge in Extremadura, Spain. The second type of the bridge is called the beam bridge, which is the simplest and the most economical bridge that rarely span more than 250 feet. It consists of a horizontal beam that is supported at each end by pier, and then the weight of the beam pushes straight down to the piers. The top edge compresses when the load pushes down on the beam, and the bottom edge will stretch. Examples of beam bridge are the Manchac Swamp Bridge in Louisiana and the Tianjin Grand Bridge in China. Next, we have the third type of bridge, which is the cantilever bridge. It has two cantilever arms. When we say cantilever, it is a rigid structural element that extends horizontally and supported at only one end. These cantilever arms extend from the opposite sides of an obstacle that has to be spanned and meet at the center. One of the advantages of building this type of bridges is that it can be built without false works, temporary supporting towers, and cables below, and in addition, these are constructed very rigid that it can carry large loads without threat for construction. Example of this type of bridge is the Forth Bridge in the east of Scotland and the Quebec Bridge in Canada. Now, let's move on to the static, light, and strong type of bridge, which is known as the suspension bridge, that can span longer than any other kind with 2,000 to 7,000 feet, but it is the most expensive among the types. As you can see, there are cables that extend from one end of the bridge to the other. The cables on the top of the high towers are secured at each end by the anchorage. The cables are made of thousands of individual steel wires. Steel wires are preferred to use because it is very strong under tension. The disadvantage of this type of bridge is its flexibility and lightness. That's why it is always a concern. Example, as you can see, uh, of the tower are the Tower Bridge in London and the Golden Gate Bridge that can be found in San Francisco. The fifth type of bridge is the cable-stayed bridge that requires less cable. It spans between 500 and 2,800 feet, quickly built, resulting in a cost-effective bridge. You'll notice that they may look similar to the suspension bridge, but they differ in a way that they support the load of the roadway. The suspension's bridge cable rides freely across the towers and transmits load to the anchorage at either end whereas the cable in cable-stayed bridge are attached to the towers, which alone bear the load. Examples are the Russia's Russky Bridge and the Sutong Yangtze River Bridge in China. And then we have the sixth type of bridge, the tied arc bridge or the bowstring. It looks like a bow from the side, and this bow uses tension of, the, of its vertical cables together with the compression of the arc supporting the load to keep the bridge stable. Tied arc bridge, as you notice, is a combination of arc and suspension bridge because of how it is formed. The example of these are the Lowry Avenue located in Minneapolis, Minnesota, and the Daniel Huan Memorial Bridge in Milwaukee. And finally, we have the seventh and the last type of bridge, known as the truss bridge with simple skeletal structure. 120 to 1,500 feet is its typical span length. This type of bridge is composed of many small beams that can support heavy weights and span great distances. Its design is also very simple. It is the ideal bridge for places where large parts of sections cannot be used, and because of its structure, the roadway may pass over, or even though the structure for clearance below the bridge. Example are the Hildburg Memorial Bridge and Bonton Bridge that is located here in the Philippines. We are done in identifying the different types of bridges. Now, let's talk about the forces that influence different bridge designs. Bridge designs are based on more than aesthetic. There are natural forces to be considered on how the bridges will be designed aside of topographical and logistical conditions on the location to build the bridges. The forces of nature that act upon bridges are the gravity, load, compression, tension, torsion, shear, vibration, or resonance. First, we have the gravity. The gravity has the most profound impact on the bridge. Gravity is constant, that no matter what the other conditions, gravity is always acting on the structure, trying to pull down. Unlike buildings, home, or a skyscraper that have ground where the building is built, the bridges have no ground beneath them to act as a counterbalance to gravity. Next, forces of nature is the load, refers to the weight of the bridge and the weight of whatever it carries. It is important to consider this before building the bridge to determine the limit of capacity of the bridge that he can carry. The longer the bridge is, the more people, cars, and other things it carries, the heavier the load is. Next is the compression, the pushing force that creates inward movement toward the center and helps other type of bridges such as arc bridge standing. But when we apply too much compression, the bridge may buckle. And then we have the tension. It is the pulling force that creates outward movement from the center. Example types of bridges that applies more tension is the suspension bridge. Too much tension also may cause the bridge to snap. And then the torsion. It is the twisting force caused by environmental forces like wind. It has the possibility that treat the structure of bridge. If the surface of bridge twists enough while travelers on it, they can be thrown off. And then we have the shear. It is the force that impairs an effect on the horizontal plane. This usually occurs when forces from environment put pressure on opposite directions on a single fastened part of a bridge. And lastly, we have to consider the vibration or resonance, the wind or movement across the bridges that match its natural frequency and vibration will able to cause resonance. In this, extreme vibrations can disrupt crossing and can possibly cause collapse in its structure. In conclusion, bridges are not just there to be a way of getting from one place to another, but they can also become a landmark because of its astonishing scenery and historical background. They can also be a geographical and architectural symbols that define us human, culturally, and historically.
So, let's now move forward to transportation engineering. But before we proceed, let us first define what is transportation. Transportation. Transport or transportation is the movement of people, animals, and goods from one location to another. Modes of transport include air, rail, road, water, cable, pipeline, and space. The field can be divided into infrastructure, vehicles, and operations. Why is transportation important? Transportation is important because it enables trade between people, which is essential for the development of civilizations. Transport plays an important part in economic growth and globalization, but most types cause air pollution and use large amounts of land. While it is heavily subsidized by governments, good planning of transport is essential to make traffic flow and restrain urban sprawl. So, what is urban sprawl? It is the rapid expansion of the geographic extent of cities and towns. So, that's why we need good planning of transport. Now that we have an idea of what is transportation, let us now move forward to our topic, which is the transportation engineering. Transportation engineering is the application of technology and scientific principles to the planning, functional design, operation, and management of facilities for any mode of transportation in order to provide for the safe, efficient, rapid, comfortable, convenient, economical, and environmentally compatible movement of people and goods. It is a subdiscipline of civil engineering and of industrial engineering. Transportation engineering is the major component of the civil engineering and mechanical engineering disciplines, according to the specialization of academic courses and main competences of the involved territory. Transport infrastructure consists of the fixed installations, including roads, railways, airways, waterways, canals and pipelines, and terminals such as airports, railway stations, bus stations, warehouses, trucking terminals, refueling depots, and seaports. Transport plays an important part in economic growth, and economic growth increases the need for transportation. Transportation systems. It can be defined as the combination of elements and their interactions which produce the demand for travel within a given area and the supply of transportation services to satisfy this demand. This definition is general and flexible enough to be applied to different contexts. And there are three modes of transport. The different modes of transport are air, water, and land transport. Land transport. Land transport covers all land-based transportation systems that provide for the movement of people, goods, and services. Land transport plays a vital role in linking communities to each other. Land transport is a key factor in urban planning, and it consists of two kinds: the rail. Rail transport is a means of conveyance of passengers and goods by way of wheeled vehicles running on a rail track, known as a railway or railroad. Examples of these are train, rail car, and rail bus. Road. A road is an identifiable route of travel, usually surfaced with gravel, asphalt, or concrete, and supporting land passage by foot or by a number of vehicles. Examples of these are cars, trucks, buses, motorbikes, and bicycles. The next mode of transport is water transport. Water transport is the process of transport that a watercraft, such as a ship or sailboat, makes over a body of water, such as a sea, ocean, lake, canal, or river. And the last mode of transport is the air transport. Air transport is an important enabler to achieving economic growth and development. Air transport facilitates integration into the global economy and provides vital connectivity on a national, regional, and international scale. It helps generate trade, promote tourism, and create employment opportunities. Let us now move forward to the branches of transportation engineering. The main branches of transportation engineering are highway engineering, airport engineering, port and harbor engineering, traffic engineering, and infrastructure engineering. Highway engineering. It is an engineering discipline which involves the design, construction, and maintenance of highway roads and systems, urban streets, as well as parking facilities. Important aspects of highway engineering include overall planning of routes, financing, environmental impact evaluation, and value engineering to compare alternatives. It plays an important role in ensuring safe and efficient transport of people and goods. Let us now look to the famous highways across the world. The Pan American Highway, which is the longest roadway in the world. Next is the Chandler Highway, which is the shortest highway in the world. Next is the Hana Highway, in which you can find many waterfalls and attractions that can be found along the way. The Katy Freeway, the widest freeways in the world, and it has 26 total lanes. Let's now move forward to the second branch of transportation engineering. Airport engineering. Airport engineering is the design, building, and maintenance of an airport facility. Airports are designed to serve a number of roles. Key functions include providing runways for aircraft to take off and land, as well as terminals for the safe loading and unloading of passengers and cargo. Airport facilities must also be able to service and maintain aircraft to keep them operating safely. Airport engineering takes into account all of these factors, along with focusing on the efficient and safe operation of the airport facility. Let us now look for the famous airports. The first one is the Hamad International Airport. It has been described as the most architecturally significant terminal complex in the world. Next is the Tokyo Haneda International Airport. It was the second busiest airport in Asia and the fourth busiest in the world in 2009. Let us now move forward to the third branch of transportation engineering, which is the port and harbor engineering. Port and harbor engineers handle the design, construction, and operation of ports, harbors, canals, and other maritime facilities. Port and harbor are often confused because they are both places used by ships and other water vessels. There are different functional aspects to each of these destinations. A port is a commercial water facility used for ships and their cargo. A harbor is a place of safety for ships and other waterborne vessels. A harbor is a mooring place and offers safe anchorage for the ships. Harbors and ports can be man-made or natural. Let us further discuss these two terms. What is a port? A port is a location on a coast or shore containing one or more harbors where ships can dock and transfer people or cargo to or from land. Port locations are selected to optimize access to land and navigable water for commercial demand and for shelter from wind and waves. Ports with deeper water are rarer but can handle larger, more economical ships. A port is a place on the coast that facilitates loading and unloading cargo. A port is usually located inside a harbor. Ports often have cargo handling equipment such as cranes, which can be seen in the picture, and also the forklifts for use in loading ships, which can be provided by private interests or public bodies. What is a harbor? A harbor, or also called as haven, is a body of water where ships, boats, and barges can seek shelter from stormy weather or else are stored for future use. A sheltered area of the sea in which vessels could be launched, built, or taken for repair, or could seek refuge in time of storms, or provide for loading and unloading of cargo and passengers. A harbor is a place that is situated on the coast where ships, boats, barges, and etc. can be moored safely. Here in this picture, we can clearly see the difference between the port and the harbor. Let us now move forward to the fourth branch of transportation engineering, which is the traffic engineering. Traffic engineering deals with the application of scientific principles, tools, techniques, and findings for safe, rapid, convenient, economic movement of people and goods. The basic object of traffic engineering is to achieve efficient, free, and rapid flow of traffic with at least no accidents. Traffic engineers are professionally trained to look at the situation and identify the problem and its cause. They take traffic counts, look at speed data, analyze accident statistics, consider roadway conditions, and even conduct further research. The last branch of transportation engineering is the infrastructure engineering. Infrastructure engineering looks at the options and processes involved in designing transport infrastructure systems that are safe and sustainable. Infrastructure engineering is professional engineering that deals with the design, construction, and maintenance of the physical and naturally built environment, including works like roads, bridges, canals, dams, and buildings. So, that concludes our report. Thank you for your time and God bless.